In this first video for rate of change and slope, we're going to be focused just on rate of change, and then the second half will be focused on slope. So in this, we're going to talk about rate of change, which is defined as a ratio comparing how one thing changes compared to how another thing changes. So you guys have probably seen this before. We think of it as change in y and y is what we consider to be the dependent variable, and then over change in x. And then x is considered to be the independent variable. So rate of change is basically like, how is our dependent variable changing as our independent variable changes? And then even shorter form, we can write this little triangle, which is a Greek symbol for delta, which we use for change. So change in y over change in x. So like I said, I'm sure you guys have seen both of those before. We're going to look at two real world examples here. So example one, it's got the number of students that applied to UCLA in 2004 compared to the number in 2006. And then we want to find the rate of change in the number of students applying for admission. So you can tell here that there's an increase. Like there's fewer students in 2004, there are more students that applied in 2006. So we want to see what the rate of change was. What was the increase like over the number of years? So we set up change in y over change in x. So we've got delta y over delta x. So if you're ever wondering which one should be the y and which one should be the x, remember y is your dependent variable. It changes as something else changes. X is your independent variable. That's something that you don't really have control over. Time is changing no matter what you do. So x is going to be your independent variable, whereas the number of students applying is going to be your dependent variable. So change in y, we had 60,291 students in 2006 minus 56,878 students in 2004. So that's the change in y. That's the change in the number of students. And then divided by change in x, which is the change in time. So this gives us a 2-year time span. So this is the increase in the number of students, then divided by the time span. So we'll plug that in. So calculator page, 60,291 minus 56,878. So over the course of 2 years, there was an increase of 3,413. And then, of course, this is a change in 2 years. So when we take that number that we just got and divide it by 2, we get, oh, well, that's a fraction form. Let's try that again. There we go. In decimal form, we get 1,706 and then 0.5. So when you're talking about a rate of change, this is students per year. There was an increase in this many students per year. So since it's a context-based problem, you always want to give some sort of units so that you know what that number means. Okay, and then this kind of explains what we were just talking about. Real world situations, you're not going to have this perfect, like, it's not like every single year this was the exact increase. That was an average rate of change over the course of 2 years. And so this is going to be the same type of idea. We've got this chart here that compares music sales for CDs and downloads. You can see that downloads are still selling less than CDs, but CDs are going down, downloads are going up, so we can use this chart to find what they're asking us for. So we want to find the average rate of change of the percent of total music sales for both CDs and downloads. All right, so average rates change between 2001 to 2008. So let's start with CDs. Okay, so you can see in 2008, 77.8% of downloads, of music sales were via CDs, and then minus 89.2. So since this is smaller than this, your rate of change is going to be negative, which makes sense because it's decreasing. And then divided by the year here was 2008, minus the year here was 2001. So if we plug that in, the numerator we get 77.8 minus 89.2. So that is negative 11.4. So it went down 11.4% over the course of 7 years. So divide by 7 years. So here's what we get. So negative 1 point, I'm going to give 2 decimal places, 63% per year. So what this means is that CD sales were decreasing at about negative 1.63% per year. Okay, and then downloads, as you can tell from the chart, downloads are increasing. So in 2008, 12.8% of music sales were from downloads versus only 0.2% in 2001. Okay, so change in time is the year 2008 minus the year 2001. Let's plug this in as well. So 12.8% minus 0.2%. So that's an increase of 12.6% over a course of 7 years. So divide by 7 years, and it's going up by about 1.8% again per year. Okay, so if you're comparing the two of these, this makes sense. There's kind of a trade-off. Fewer people are buying CDs because more people are downloading music. So you can see that these are actually really close to being the same number. Okay, so that's it for the first half. Okay, so in our last video, we dealt with kind of generic rates of change, especially when they were in application problems. We're going to be talking about slope of lines, equations, y equals mx plus b. So this is going to be dealing more with variables and equations than actual real-world applications like the last one was. So I'll show you kind of a picture here. So say we've got a line, looks something like this. If we want to find the slope of the line, what we do is we pick out 2 points. So let's say this point right here is the point x1, y1. And then pick another point, and we'll say this is the point x2, y2. Okay, so if we wanted to find the slope between those 2 points, we would use these actual coordinate points in a formula. So if you are trying to find the slope, we've got a bunch of different ways we can define it. We can define it as change in y over change in x, like we did in the previous set of notes. We can say, yeah, let's write that. Okay, so change in y over change in x, same way that we defined it up above. Since we're on a coordinate plane, you can think of this as like the change in the 2 y coordinates and the change in the 2 x coordinates. So change in y means the ending y value minus the starting y value in the numerator, and then change in x is the ending x value minus the starting x value. So this formula I'm really hoping is familiar. And so what this gives you, it gives you basically the steepness of a line. So the bigger this number is, the steeper the line will appear. We can also have positive or negative slopes. This would be a positive slope. If our graph was going the other way, it would be a negative slope. And then, just so you know, we have 2 other types of lines. Most of our lines are diagonal, so they'll have some sort of numerical slope. We could also have horizontal lines. So a horizontal slope is 0. So if you just have a straight line, there's no change in y. And since there's no change in y, the numerator would be 0, so your slope would be 0. If you have a vertical line, we say that's undefined. Okay, so those are 2 sort of special cases. You could have a horizontal line or a vertical line. Horizontal lines have a slope of 0, vertical lines have a slope that is undefined. And same thing, if you were going straight up and down, there's no change in x, so your denominator would be 0, which of course is not something that we can do. So let's use this formula to find the slope between these 2 points. So I've always found it easy to just take the points and kind of label them, like label this x1, y1, label this one x2, y2, and then, you know, everything can just kind of slip into the formula really easily. So let's write the formula first. And just for quick and easy reference, instead of writing out the word slope, we've always used m to define the slope. So here's our formula, y2 minus y1 over x2 minus x1, and then since we've got everything labeled, we can just sub them right in. So y2 is negative 2 minus y1, which is 4, over x2, which is 1, minus x1, which is a negative 1. Okay, so negative 2 minus 4 is negative 6, over, and then 1 minus negative 1, remember that changes to plus a positive. So we get 2, and then that reduces down. Negative 6 divided by positive 2 is a negative 3. So the slope between those lines would be a negative 3. So that means, first of all, that it's sloping the opposite way that this line does. It means every time my x value goes up 1, my y value goes down 3. That's what that slope means. Okay, let's look at some based off of graphs with example 4. Okay, so basically we're dealing with the same thing, but instead of having 2 ordered pairs, we just have a graph in front of us, so we have to figure out where the ordered pairs are. So if we pick, you want to look for a place where it crosses like right through the corners. So this one, let's see, looks like it crosses through a corner right there, and it looks like it crosses through a corner right there. Okay, so when you're trying to figure out slope, you want the change in y compared to the change in x. So change in y is how many units you go up or down. So from this point to this point, we go up one box, the difference between these two, but you can see on the label, this is not actually 1 unit, this is supposed to be 2 units, because it's labeled as 2, 4, 6, 8. So change in y, you go up 2 units, which means a positive 2, and then over to the right, 1, 2, 3 boxes, but again, look at the scale, it's actually 2, 4, 6. And 2 over 6 reduces down to 1 over 3. So it's basically like a ratio thing. It's like every time y goes up 1, x goes over to the right 3. And it would repeat that pattern. So it would go up 1, over to the right 3, just like that. Okay, let's look at this one. So same thing, you want to find points where it looks like it's crossing right through a corner. So it looks like it's crossing through right there, and maybe right there. Okay, so we're trying to count change in y compared to change in x. So change in y, from this point down to this point, I go down 1, 2, 3, 4 grids. There's no scaling, so we know it actually is 4 grids. Remember, going down means negative. So I go down 4 units, that's a negative 4. And then after I go down 4, I go over 1 to the right. So my change in x would be a positive 1. Going to the right is positive. So that we can just write as a negative 4. So again, what that means is every time y goes down 4, x goes over to the right 1. And it repeats that pattern over and over. All right, let's look at the last one. Kind of a challenge problem here. Find the value of r. So like there's a missing value in one of these points, but we know the slope. So let's set up the slope formula. We're going to be using this. This is something that should absolutely be memorized as soon as possible. So here's what we know. We've got our first point, x1, y1. Remember I said it helps to label them. This point we can write x2, y2, and then this is m. So rather than what we were doing on the previous page where we know all this stuff, but we don't know this, we know what the slope is, we're missing one of these pieces. So let's fill everything in that we know. M is 1/3. Y2 is what we don't know, that's r. So we're just going to fill in an r, and that's our variable that we're going to solve for. Minus y1, which is 1, over x2 is 5, minus x1 is 8. So we get all that filled in, and then we can simplify. So we've got 1/3 equals r minus 1. We can't really do anything with that. We just write it exactly the way it is. Over 5 minus 8, which is negative 3. And then what we're trying to do here is we're trying to get the r by itself. So since it's in a proportion here, we can cross multiply. So multiply these two together, distribute the 3 to the r minus 1, and I get 3r minus 3 equals, and then multiply these two together. 1 times negative 3, we get negative 3. So just a couple steps to get r by itself. We can add the 3 to both sides, and if you look, what happens here is they both cancel out. So all I have on the right is a 0 technically. And then I have 3r equals 0. So really quickly I can divide by 3 to get that r by itself. 0 divided by 3 is still 0. So the value of r that's missing is actually a value of 0. So that completes that slope formula.